Good morning, good afternoon, or good evening, whenever you're tuning in. Today's topic is 2.15. I'm Miss Hernandez, chemistry teacher at La Jolla High School. And I'm working again with fifth period. It's one of my favorite classes to record. It's a small class, and they're a really good bunch of kids, okay? Even though sometimes leave they leave our virtual classroom before they're supposed to, Hanya. Um, but let's get started with today's lecture. Today's lecture is 2.15 chemical symbols and chemical formulas. It's going to be a basic introduction into the symbols, which we've already kind of talked about, and formulas. We're not going to learn how to write formulas today. All we're going to do is we're going to learn the basics about formula. All right, so let's start off with today's introduction. How do chess players monitor their moves in a game? I don't know about you, but I had no idea that you could actually write down the different moves that people make and keep them, to as a study guide for your next match. That's something I learned that's new today. Is anybody here play chess? Does anybody here play chess? Or is in the chess club? No? Nobody in here is in the chess club? All right. Well, I know how to play checkers. I do not know how to play chess. So, I'm still waiting to learn. I need one student to help me out with reading today's introduction. Who's going to help me today? Melissa? Are you there, Melissa? Okay, I guess she's not there. What about Caitlin? No. Or let's do it. Alexia, you've been doing. You're my helper today. Help me out, Alexia, and talk to me about chess. Alexia, are you there? Okay. I guess she's having some technical difficulties. All right, so I guess I'll do the reading. Suppose you are walking along and you notice a piece of paper on the ground with markings on it. You pick it up and you see the paper in the picture above. To most people, these notes are meaningless. They may be a secret spy code, who knows? But to a chess player, these symbols tell a story of a chess game. Each abbreviation describes the chess piece or a move that happened during the game. The use of special symbols allows us to see the game without having to read a wordy, impossible, incomplete description of what happened during this game. So if we look at it up close, and let me see if I can zoom it in a little. Oop. So check it out. If you look at it closely, you can probably see that it's most of them have like two letters and then a number. So maybe the first letter is the chess piece, the second letter is a position on the board, and the third number is maybe like a number on the board as well. Okay, like I know when I've heard people play chess, they're like rook to L9. Okay, so we know that on the board there are letters and there are numbers. Okay, so we're assuming that that first letter is a particular chess piece. Okay, and do we know exactly what chess piece? No, we can only assume that it's going to be, a pawn, the king, the queen, or whatever it is. I don't know. I'm not a chess player. But those symbols represent something else, just like in chemistry, right? When it comes to chemistry, we have symbols, we have element symbols, right? They can also be known as chemical symbols, right? Depending if it's like a formula or something. In order to illustrate chemical reactions and the elements and compounds involved in them, chemists will use symbols and formulas to tell you what's happening in a particular reaction. What is a chemical symbol? A chemical symbol is a one or two letter designation of an element. Okay. And now, with all of these 118 elements, we have some elements that have three-letter designation. Okay. So it's not just one or two, it can possibly be three-letter designations. Some examples of chemical symbols are O, right? If we see the letter O in a chemical reaction, we're going to always think of oxygen. If we see the letter ZN, ZN is for the element zinc. And if we were to see the abbreviation or the symbol of Fe, we're going to assume that that's iron. And in case you ever forget what a symbol's name is from its or what the element's name is from the symbol, you always have the periodic table available so that you can verify the name of whatever element you're dealing with. The first letter of a symbol is always capitalized, right? In the case of oxygen, we just have a capital O. In the case of zinc, Z is our capital letter, and for iron, F is the capital letter. If the symbol contains two letters, like zinc and iron, the second letter is always lowercase. For zinc, it's got a small n. For iron, it's got a lowercase e. The majority of elements have symbols that are based on their English names. So most of these elements, we can easily figure out who they are because those symbols are based off the English name. However, some of the elements that have been known since hundreds and thousands of years will maintain symbols that are based on their Latin names. So if you see an element that has a weird symbol that has nothing to do with the name, that's probably because that element has been around for hundreds of years and it's based off its Latin name. And we're going to talk about some examples. For example, in the case of sodium, Na. Sodium has a symbol of Na. Why? Because the Latin name is natrium. For potassium, we have the letter K as the symbol because of the Latin name kalium. When it comes to iron, we use Fe because of the Latin name ferrium. Copper is Cu because it's called cuprium in Latin. Silver is Ag because in Latin it's argentum. Tin, Sn, is strontium. Antimony, Sb, is stibitium. Gold is Au because it's arium in Latin. And the last one that they have here is lead, Pb, because in Latin it's known as plumba. So all of these elements in this table have been around for hundreds or even thousands of years. That's how come they have different symbols than their name, than their English name, because those symbols are based off its Latin name. Any questions, guys? Any questions? All right, we got a short video that's going to tell us some more examples of other elements and their origin.
Scientists have discovered over 100 different elements. They're named after all sorts of things like colours, planets and places. But as a shorthand, scientists use symbols. The letter H for hydrogen, C for carbon, and O for oxygen. But the names and symbols don't always seem to make sense. Silver's symbol is Ag. Ag comes from its Latin name Argentum, so it's no surprise the place where loads of silver has been found is called Argentina.
Wow, I don't know if you can hear it through her accent, but there's a lot of the silver that's produced in the world comes from Argentina. That's why it's called Argentium. AG.
One of James Bond's enemies is Goldfinger, and his first name's Alric. It's a bit of a weird name, but it was probably chosen because the symbol for gold is AU. The Roman...
My husband loves James Bond, and I did not know that the actual name of Goldfinger was Auric, and now it's making sense because of that AU. There's all these little hints that movies give us that relates those elements to their symbols.
It's called lead plumbum, which is why its chemical symbol is Pb. Before lead was found to be poisonous, it was used for most water pipes. So from the word plumbum, we get plumber.
Sr is a symbol for the element called strontium, named after the town Strontian in Scotland, but I like it because it's the element that makes fireworks red. Br is a symbol for bromine. Bromine gets its name from the Greek word bromos, which means stench, because bromine stinks.
All right, so those are some fun facts about some of those elements, their names, and their symbols. So let's talk about here chemical formulas. Chemical formulas. Compounds are combinations of two or more elements. We know this. We've studied a whole section on just compounds. A chemical formula is an expression that shows the elements in a compound and the relative proportions of those elements. So what does it mean when they say relative proportions? Is that they tell you how many of each element there are. If you have a formula that's like CH4, well, they're telling you that C is carbon, and since it doesn't have a number behind it, you always assume it's a 1. So there's 1 carbon, and the formula is CH4. So that means the second element is hydrogen, and since it's CH4, that means there are 4 hydrogens. In the case of water, water is composed of hydrogen and oxygen, a 2-to-1 ratio. That just means that the formula is going to be H2O, meaning for hydrogen, we have 2 atoms. For oxygen, just 1. Remember, if there's no number after that element, that just means that there's only 1. Sulfuric acid is one of the most widely produced chemicals in the United States and is composed of elements hydrogen, sulfur, and oxygen. And the chemical formula for sulfuric acid is H2SO4. How many hydrogens? Well, what's the number behind it, guys? Hello? How many hydrogens do I have in this formula today, guys? I didn't hear you, Hanya. How many did you say? And you could type it in the 2. Thank you. What about for sulfur, Hanya? If there's no number, what do you always say?
1.
And for oxygen, we have
1.
4. Exactly. Thank you so much, Hanya. I don't know. Yeah, Alexia might be with her brother. That's why she's not answering. But either way, I got Hanya. She's not going to be disappearing on me today. All right, so let's talk about elements that you need to be familiar with. So let's open up Jamboard because there are some elements that you need to be familiar with. Not all 118, guys. I'm not telling you have to know the chemical symbol for all 118. No, it's only about 60 something. And most of these you already know, like carbon, boron, all of those you already know. Aluminum, Al, sulfur, phosphorus. All right, so grab a highlighter or even just a pencil, and let's highlight the elements that you need to be familiar with, okay? So, the first element that you need to write down, if you have your packet, go to the page at the beginning of your packet that has the periodic table. I think it's like page 4 or 5 at the beginning of your packet. So, you're going to need to know, first off, number 1, and you're going to need to know all the way up until krypton. So you're going to need to know helium. You're going to need to know 3, 4, 5, 6 through 10, 11 and 12, 13 through 18, 19, all the way to krypton. Okay, then we're going to be doing some jumping around, so make sure you can keep up. Rubidium 37 and 38, definitely need to know those. You also need to know starting at 47 all the way to 54. Do you need to memorize them? No. Do you need to be familiar with them? Yes. Cesium, tungsten, and then here where it says platinum, all the way to number 86. All right. Now, francium and radium are also on the list. Okay. And we need 2 more. We need number 92, uranium, and we need number 94, plutonium. Okay. Those 2 elements are important because that's what we use in like those nuclear bombs that the military has. Some of those are made of plutonium and uranium. And uranium is a very important metal that we it's a fossil fuel that we use for different purposes, okay? So you need to be familiar with that. All right, did everybody write that down? Did everybody get that? If you don't have your periodic table, just write the numbers 1 through 38, 47 to 56, and then we have 74, and then 78 through 88, 92, and 94, and that's it, okay? If you can be familiar with them, we might have a Kahoot later next week, and we could see how many have been studying this periodic table, okay? And do you have to memorize it? No, because usually I'll give you a name, and all you have to do is tell me what symbol it would go with, okay? Or the opposite. I give you a symbol, and you have to know the name, okay? But it'll always be like multiple choice. I'm never going to just leave you out like that. All right, let's talk about formulas next. If I have a formula, first off, only the letters should be large. Those numbers are known as subscripts, meaning they need to be small and they need to be at the bottom, okay? I don't want to see you write water like this. That's not how you write it. That's wrong, guys. If you're going to write water, you're going to write a big H, a small 2, and a big O. Do you notice the difference? Does everybody see the difference here? If I were, here, let me erase this. If I were to talk about number 1, check out number 1. It has parentheses. So we got to treat it a little different. All right? So we're going to put NH, a small 3, parentheses around NH3, and then we're going to put a small 2 on the outside with an O. Now, if I were to count how many atoms, how many of all the elements do we have? Okay? Now, remember, we said if there's no number, we always assume that there's a number what?
What?
Thank you, Hania. So that means that nitrogen is a 1, oxygen is a 1. But now we have this new thing, these parentheses around NH3. Everybody see those parentheses? Do you notice how there's a number on the outside? we need to multiply the numbers on the inside with the numbers on the outside. So how many nitrogens do I have if I multiply 1 times 2?
2.
Great. So I'm going to put a 2 right here. How many hydrogens do I have? Well, what's 2 times 3?
6.
All right. And how many oxygens do I have? 1, right? So if I were to add those up to find out how many total atoms are in this compound, well, what's 2 plus 6 plus 1? 2 plus 6 is 8. 8 plus 1 is 9. Thank you, Hania. Be careful when you see those parentheses around those compounds, okay? All you have to do is multiply the number on the outside with the number on the inside. Okay, let's do one more. One more. Okay, I just want to make sure we have enough time to do the questions, okay? Because we are going to do the questions together. All right, let's do number 5. All right, if I do number 5, I'm going to write TI parentheses, capital C, capital N with a 4. Okay, so that means I have 1 titanium, 1 carbon, and 1 nitrogen. So I'm going to put a 1 for titanium because it doesn't have to multiply. It doesn't have parentheses. Why? Because it doesn't have parentheses and it doesn't have a number outside those parentheses. The number outside the parentheses is only going to multiply with what's inside the parentheses, okay? So if I have carbon with 1 and I multiply it times 4, well, what's 1 times 4?
4.
Good job, Hania. And then if I have, again, for nitrogen, 1 times 4, how many do I have? For nitrogen. N.
4.
And if I were to add those up, Hania, what's 1 plus 4 plus 4?
9.
Thank you. Any questions on formulas, guys? This is as hard as it will get as far as formulas go. Okay? Any questions before we continue? Any questions? All right, let's stop there. Let's go back to the summary. So in summary, a chemical symbol is a 1 or 2 letter designation of an element. Compounds are combinations of 2 or more elements. A chemical formula is an expression that shows elements in a compound and the relative proportions of those elements, meaning how many there are. It tells you the numbers, right? Many elements have symbols that derive from the Latin name of that element. So you got 4 questions to do. 2 of them are definitions, and the other 2 are super easy questions. Try it out. Those of you online working by yourself, let me know if you need any help, and I will be happy to help you. All right, so let me